usually over under one shuttle table. We have one that's higher and lower. This one raises and or lowers to make sure the same cut height is the same at the laser, correct?
Right.
Okay.
That's really the way all the machines work, even without automation. The next sheet load in on the shuttle while that was running.
Yeah, that's what I was kind of interested in, is the actual per pallet, per distance.
Looking at about 3.5 minutes is what you can figure.
Okay.
And I need 3.5 minutes
to unload
a sheet
and load.
And prepare the next sheet.
Okay.
So as long as your programs are more than that,
yeah, which I think,
at shuttle time.
Yeah, and I think that aluminum was going to be our only, but like I said, we're still cutting through it like butter. That the speed cutting will help offset the maybe a teeny bit extended by doing it by hand. But I still think it's going to be faster, even with automated.
Oh, by far. When you look at it ain't got to take a break.
Exactly. You could save all your aluminum cutting for night and dump it right over top of each other or whatever, yeah. So yeah, we could go to an 8-hour fab and let the thing run the rest of the time until it faults out or what, you know, as long as we're stacking them on top of each other, it's not a concern. Get an extra 2 hours unmanned or 1 hour or just whatever's needed. Just only cut and do what's needed at the time. So it does thickness check and all that stuff too. So if we're using this machine primarily for our stainless, the actual grippers that grab the bottom of the part, what is that made out of? Is it painted steel or what is it? Okay. So I'm wondering what issue. I mean, like I say, a shear blade, you know, is made out of steel, so I don't know how big of an issue it is, but when we go to pick up our parts, you know, and it's carbon steel contact, just like we're going to skin those out, I'm wondering will we have to do some kind of a tape, stainless steel tape or something, maybe, possibly, or, I mean, nuclear guys, you know, they're crazy about this stuff. I just don't know.
As far as that goes,
oh, couldn't we take that out and couldn't we fabricate some stainless one? I mean, if that was important to us, I mean, we could get that DXF for that and make our own stainless steel grippers, maybe. I mean, it's overkill for what you would sell it that way, but if we chose to do that on our own, is that molded up?
I don't even know that you would have to do that to remake stainless tube, because that's just tube.
You could do a stainless steel bar and
all you got to do is do a little channel, just to lay down over it. Just make 3-foot channels, that many sections, you know, and then just pop it down over the top of each fork.
Yeah, we can do that.
A little double-sided tape. I mean, if
we do everything overkill, that's what I was saying. They'll throw some crazy labor on something just to say that they did it. But.
Right. So here's your unload. So see, I'm even on the unload. I'm actually just lifting it up. Here is where you would have any issues is in the unload, because it actually drags it off the forks. The forks are going to separate.
Yeah, as long as it's just picking it up and touching it. But I mean, they call it contact, so we would still want to.
I got you. I can see it's coming down the height.
But the labor to even reverse engineer that just to do exactly and make our own stainless steel, be all over that. We would do that and run it through a work order and run it through, because it's a one-time thing. You won't ever have to do it again.
Right.
I think that would be what we probably do. And if it drags stainless against stainless, it's not an issue. Like I said, nuclear NQ81 forces us to do all kinds of crazy stuff.
I got you.
But that's a cost of doing business on our end, so we'll eat that. That's
So that's the process.